Hey everyone, thank you for being here. My name is Andrew Kittredge. I work at Beta NYC. Thank you for everyone here at DCP for putting these events together. The first one's been great so far. I'm looking forward to the rest of them today. NYC Open Data is a collection of free public data sets that allow anyone to learn about how New York City works. Open Data Week in particular is a celebration of that open data. It's co-organized by the Open Data team at the Office of Technology Innovation, my organization, Beta NYC, and the Art Collective Data Through Design. We kicked off Open Data Week last week with this year's Data Through Design exhibit, Corpus. New for this year, it's up for 2 weeks. So not only can you check it out through the rest of official Open Data Week, but next week as well. We are closing out Open Data Week on Saturday with Beta NYC's in-person conference School of Data. So if you've been enjoying the events so far in Open Data Week and you want to meet other people who've been enjoying them as well and see some great talks, I definitely recommend grab a ticket, and I hope to see you Saturday. And I'll turn that over to you all. Thanks so much.
Hi, everybody. I'm Alex Ritchie. I work on the data engineering team at City Planning. I'm going to be talking about automating data distribution to open data. I'm going to be giving this talk with Damon McCullough. We've worked on a lot of this stuff together. So here's the requisite slide with the caps. That's me and the socks. And then Damon with Nabu and Devika. I'm going to, shameful admission, I don't know which is which. So that's us. And then as a department, who are we? This will be a bit of a recap, but we're City Planning. We're the primary land use agency. We are responsible for planning growth. We're also a data producing agency, so we act in an advisory role for other agencies. We provide them data sets, and we have a really long history doing it. That's us as a department, and us as a team. No surprise, we're data engineering. We produce some of DCP's greatest hits, Pluto, facilities database, housing database. And so I wanted to call out again that we're one of the open source teams. So in contrast to many teams in the city and even at DCP, we, more than others, rely on open source where possible. And then just to call it again that, like, we do both infrastructure and transformations, meaning we do exploratory data analysis, we do stuff in databases, writing queries, et cetera, but we also are responsible for the infrastructure for getting our data sets from start to finish. And I have either very good news for you or bad news. This is an infrastructure talk. So if you're into the transformation side of things, you may be a little bit out of luck here. So this might be familiar if you were around for the previous talk. It's a lot of familiar faces. So, we've talked about our data sets from start to finish, going through the life cycle. And I promise you there is a cycle, even though this looks very much like a straight line. But Finn and Sasha talked about ingest, sort of that first phase of the life cycle. And Damon and I are going to be talking about packaging and distribute. So this is the last mile. And what that means really is, just to recap, sort of, so Finn and Sasha were talking about phase one, ingest. We didn't touch on building at all. So what we mean by build is just really like, we chuck a bunch of this ingested data into typically Postgres. We run some queries and then we spit stuff out. That's where build ends, and this is where this talk begins. So we're talking about packaging and distributing. So packaging, this is what we call when we create sort of a curated set of files, some of them generated at time of packaging, so your data dictionaries, READMES, et cetera. It could also be sort of light cosmetic modifications to files existing. So maybe we have a shapefile and a CSV out of Pluto, and we need to change some column names, et cetera. It's these sort of small little like zhuzhing of the data set to get it into a state in which it can be distributed, which is the final stage of things where we're just chucking the data over to like open data. So really pushing packaged files to destinations like, say, we have an internal FTP server or a database or open data. And so just to make that really concrete, what we're talking about here. So Pluto is our flagship product. What you're seeing on the left is sort of representing the build phase, where we take in about 35-ish data sets, dump them into Postgres, magic happens, and then we have kind of a messy group of files. It's just the stuff that we exported raw from a database. This isn't necessarily fit for consumption of the public. The packaging phase is where we turn it into something that we're fine handing to the public, and also something where we're happy to distribute it to something like an FTP server or open data or Bites of the Big Apple, which is city planning's, but our agency website for hosting the data. So this talk is just really about the challenge that we had, and I've been leading this project for the last year, and the impetus for it and the challenge is just that for these last two phases, we want to have everything automated. We're not quite there, but the road is sort of paved for it. And so, why is that even challenging? I'm sure many of you have familiarity with this, but we work with a lot of data. So we have up over 100 data sets that we publish at different cadences. Each of those data sets might have a set of different formats. So for Pluto, we might spit out a few different data. We might spit out a shapefile, a SQL dump, all of these things. And for legacy reasons, maybe some of those have to be slightly different. Like maybe we have a standing agreement with a different agency that we will give you a CSV of this data, but all the column names will be upcased except this very last one. It's not ideal, but it's the world that we live in, and I'm guessing you do too. So, that presents challenges like what does a data dictionary even mean for something like that? And then there's the added complication that all of those files have to go to potentially many places. And so we might send them, like we said, to open data. We might send them to a Postgres database for our app team. We might send them to an FTP server for a different agency. And so when you kind of multiply the number of data sets times the number of destinations, even if the number 100 doesn't seem daunting at first, it kind of gets unmanageable very quickly. But then there's the added complication that, say I have pushed this CSV out to this different destination, to like an FTP server, how do I actually verify that what I pushed is correct? Like, how do I know that it has the correct columns? Which all leads us to the general animating problem here is we didn't have a source of truth for metadata about our data sets. So, how do we actually formally describe what Pluto is? You might have found a few different descriptions for Pluto in a few different places, depending on where you looked. Same for any given column in Pluto. So why are we giving this talk? We've been working on this for a while, and in, I'd say, the last few quarters, we started to think a little more in terms of open sourcing this. And we made tools that you might find useful. And tools might be a little bit reductive because we both created tools, but I think a lot of the concepts we kind of worked out might be more broadly applicable. So I hope that maybe you can come away with, if not tools that you can actually use, just, hey, maybe you know how we describe certain aspects of the life cycle. But in general, the sort of existing tooling in the world didn't meet the needs that we had. So, it would be wonderful if there was just a library that would do sort of end-to-end data, like life cycle management. Doesn't, to my knowledge, exist. And the Python libraries that we need to actually push data or manipulate data often are maybe 90% of the way there. Maybe we have to, wrap them. We have to make some modifications to them to get them to do exactly what we want to do. And namely Socrata in this case. Then over and all above, when we were just talking about these things as a team, we had substantial disagreements on what we even call these various things. So existing vocabulary for what we call different phases of the life cycle, what we call different, like what even is a data set? That type of thing. There are existing vocabulary and standards for those things, but they didn't really meet our use case. So who is this talk for? It's mostly aimed at other data engineers or sort of people software adjacent. That could be potential users of DCPy. And I'm so sorry, Sasha, I didn't know that this portmanteau wasn't, DCPy and Python wasn't, yeah, I think we were just too clever. But, so, you know, I think this talk is aimed at other potential users of this or potential contributors. And then in addition, just data practitioners. I think we all don't love this term, but what I mean by data practitioners are just people sort of adjacent to software like data engineers. So these could be analysts, managers of data lifecycle or any sort of department. And you might be interested just to know how we do things, what we call things, et cetera. So a few disclaimers. There is code in this, but from what I've heard just in the sort of chattering, you all seem like a very technical group of people. So, but even, you know, we will be talking about Python and YAML, but we'll try to keep it generalizable to some concepts that sort of everyone can take something away from. Also, please don't use this as documentation if you go to use the library. So, you know, just for brevity and to really like illustrate the concept of a point, a lot of the code is sort of truncated just to make it clear what we're going for. All of the code referenced is open source, yay. As in you can go download the source, but there is a little bit more that goes into making something truly open source in terms of usability, and we're currently working on that. So just another note, we will reference Pluto a lot. There is a talk about Pluto. This is not it. We're happy to give it, though, if you're interested. And then sort of similar to the ingest talk, we'll be talking about most of these examples in the context of DCPy, which is our Python package, and specifically the lifecycle module within it, and sort of those phases. But that said, like the code is, I think we've done a pretty good job at modularity and sort of separation of concerns. So if there is some bit of it, some little bit of like functionality that might sound applicable to you, you don't have to buy the full farm if you want to make use of it. So yeah, I'm going to hand it over to Damon, who is going to talk through sort of the beginning of the solution for all of this.
Thank you for the setup. Hopefully everyone can hear me all right. So a few things about our solution. Product metadata. And like Alex said, the value of shared vocabulary is very significant to us. And what we mean by product is a data product, a collection of data sets. Because when we put out something like Pluto, are we talking about Map Pluto? Are we talking about Pluto, the CSV, the file geodatabase? It's an endless question, and so we've decided that data product is a collection of data sets that have a common name like Pluto. And so defining metadata or data about data for these products became central to solving the problems that Alex talked about. And so we've called this a new standard for us for describing our data sets. We can define attributes at 3 levels: the data set, the column, and the destination that that data may be sent to. And that lets us mix and match specific qualities of those levels. And our code uses that metadata to package files and distribute files. And so that metadata drives this section of the lifecycle. And so the diagram on the bottom is a piece of what you saw earlier, where there are build outputs on the left, a messy collection of files that came straight from a database. Then there are cleaner packaged files that are ready to distribute to different destinations. And you will see YAML eventually, I promise, but these stages are driven by what we could say is a single file that represents attributes of the package data and the destinations that it's going to be distributed to. And so this example of Pluto, again, one of our favorite data sets, we see a short text description that is easy to modify of the attributes of this data, the description of Pluto, the display name of it. Each row is a blank, one of my favorite qualities of a data set to describe, because that should be your first question of what is this, and tags of that data. And we see that these types of attributes are what populate the open data page. And down a level to the columns, this is a Burrow block and lot BBL column where we can specify a data type, a custom data type which lets us validate specific qualities of that column, not just text or integer, and the description of it. And these exact same things are what end up in, again, the open data page. So this isn't just about distributing data, it's about distributing metadata as well, so that people can understand what data they're using. And so DCPy is the Python package that we've created for our team to manage the life cycle of our data sets. And again, DCPy, for those who don't know or are curious, DCP and Python. A long history of Python packages, including some version of Python in the name, for better or worse. And so DCPy lifecycle, again, is our set of Python utilities. In this case, a Python package for packaging and distributing data. And like we heard about in an earlier talk, we didn't want to just live and die by Python code. So what you're seeing here are examples of command line arguments, where if somebody just writes a YAML file with all of the details they need to write and runs a command line argument, they didn't have to write any Python code to use this Python package. And there was a question in the earlier talk about design decisions, and I'll just note that we're inspired by packages we use, like dbt, which we would love to give an entire talk about, like Pluto, but some of the inspiration here is not forcing every user to write Python code to use the utilities we've written. And so this first example is just using DCPy to package Pluto version 25v1 or distribute Pluto 25v1 to open data. So a little bit about packaging before I hand it back to Alex for distribution, the star of the show. Again, packaging is creating a curated set of files that are ready to be distributed. We might modify files that are produced during a build. We might generate assets like data dictionaries, the Excel sheet that should be generated for every data set on open data, or a PDF that an agency might want to customize to have certain images or text in it. File validation is another favorite of ours, and we have some examples of that. And then combining and zipping files together. And you might wonder, shouldn't you do that during the build? In some cases, we do. But we don't control all builds. We might package and distribute data that we get from the GIS team. And so rather than cutting off the capabilities and saying, well, everything should be done during a build, we'd rather be able to do it later and have the flexibility in this stage called packaging to get things ready for what we want to be a simple stage, distribution. And so just an example of Pluto packaging. Again, on the left, we have the files that come out of the build for version 25v1 of Pluto. And this is a screenshot of files in our S3 bucket. And in the middle here is just a piece of a much larger YAML file that is describing the assembly of files when they're being packaged. And so we have a PDF noted here as some of the contents, a certain file name that we give an ID so that it can be referenced in other sections of that file. And they end up as the beautifully curated files on the right that are ready to be distributed. And I'll also just flag again that this isn't just about renaming and moving files. It's also about generating new ones like these Excel files and PDFs that are mostly populated by values in that metadata, but are principally filling in templates. So we might start with a blank open data template that we fill in with specific metadata for that data set. And these are those data dictionaries that are generated during the packaging phase. This PDF is very in progress, but nice to see that it's possible. And so I mentioned validating data, and I'll walk through these three images. On the top left, we have a very zoomed in description and data type for the burrow block and lock column of Pluto data. And this data type BBL is not the usual data type. It's not a data frame data type. It's a very specific string in our case. And we can define some validators for these data types. So this is Python code in the top right, where we're describing a validator for that BBL column, saying that strings in this column must match a specific regular expression. And there are packages like Pydantic to do these types of things, or just custom Python code that you write yourself. And this is one way that we can validate values in a column when we're packaging it. And these are things that you could validate during a build to a certain degree, but if you'd rather do it in Python, and if you don't have as much control over the build as you'd like, you can do these things after it's built. And the screenshot on the bottom is from a GitHub action. As Finn mentioned, we use GitHub actions as much as we can as our practically free infrastructure to run so many of these stages. And this is an example of packaging failing because of invalid data in certain columns. So in this case, app BBL contains many, many values that do not conform to type BBL. For example, this string with very unnecessary zeros after. And it's not a string, it's a float or a decimal. So this is an example of validation failing during packaging. And so just a few concepts that we covered here for packaging. We're mapping between build and distribute, mapping files and data. We're validating that files exist in the first place and the content of them. And we're generating assets like data dictionaries. And like Alex touched on, a lot of the value here is that we're defining these things in the first place, that we're writing them down. If code uses them, great, but just the fact that we're writing it down to have one source of truth is already very, very useful. I'm going to give it back to Alex for distribution, and we'll keep going.
And I'm so sorry, I just realized that I'm doing free advertisement for whatever water company this is. So yeah, distribution, this is sort of the phase that happens after packaging. And just what I'm going to talk through here is, what do I even mean when I say distribution? And sort of introduce the concepts and the words that we use, just the most important ones. But we're going to really frame this in the context of the module, DCPy lifecycle distribute, sort of what you'd see if you peeked under the hood of the code base. And show me an example. Yes, I will. And then after that, we're going to talk through just what does it actually look like when we automate this for open data. This is sort of the reason for the season. And for that, we're going to just take a look at the open data or Socrata connector and sort of walk through the flow for publishing data there. So what is distribution? Just it's sending your data somewhere. So this could be Postgres, whatever, open data. A little more precisely, really, this is what you'll see if you look in the code base. To be very specific, it's connectors sending packaged data to destinations as defined in the metadata. And so I think the three key concepts are these bolded words for distribution. So diving in just to describe what those words are, so a connector is just code that pulls and pushes data with a somewhat standardized interface. And they do a little more than that. So typically we want them to be able to query versions or something like that. But the most important job of a connector is to push and pull data. We mentioned destinations. A destination in our parlance is just a place where your data goes. So it'd be an open data page, an app database table, an SFTP server at another agency, and then metadata. This is just really our declarative format. This is YAML that tells the connector what to do. So it tells you what files you want to send, where to send them, and then any other configuration details that we need. So we really worked hard to make sort of the details of where and what we're pushing as declarative as possible, just to upfront that all into something that is version controlled. And so just a quick aside about connectors. I mentioned they push and pull data, and the other bit to mention here is that they live in DCPy lifecycle, they live in a connector registry. And they do this because we want to use connectors for every phase of the lifecycle. So Finn and Sasha's ingest code makes use of our shared connector registry. And just when I say registering them, it's just, that's how our code becomes aware of a connector. So just to recap, this time with a graphic, connectors sending packaged data to destinations as defined in metadata. Over on our left, we have some of our metadata describing a destination for, in this case, Pluto. So we have a destination called Open Data. It's of type Socrata.OpenData. We specify what files we're going to send and what they're going to do when we send them. So we're going to send a Pluto README that functions as an attachment. We're going to send a CSV that functions as the dataset file, and we're going to send it to this 4.4. So to just diagram that out, we have connectors. We have an FTP connector that pushes to FTP, bytes connector that pushes to bytes. It doesn't actually yet, but it will. And then an open data connector that pushes to NYC Open Data. So asked for an example, and this one makes use of the most glorious data set of them all, which is the New York City squirrel census. If you're not aware of this, this is, in 2018, an intrepid group of, I think, non-scientists decided to track the squirrel occurrences in Central Park. And so each row in this data set is a squirrel sighting. So just my absolutely contrived example for you is, say your boss comes to you and says, we have a new data set, it's the squirrel census, and we have a new database, Snowflake, and we want you to put the squirrel census on Snowflake in a way that's repeatable. So, so what would it look like to implement this with DCP lifecycle distribute? So roughly, we just need metadata. Again, this tells the connector which files in the package to push and where they go. So it's the destination. And then we need to, since it's a new database, we need to create a new connector to actually push that data. We're going to push squirrels.shape to Snowflake. So here's a swing at what the metadata would look like for this. So we have squirrel census, a few attributes about this data set. So the description of census of squirrels in Central Park. Each row in this data set is a squirrel. And the destinations for it would be our new Snowflake DB, which is of type Snowflake. And we detail out the files that we'd like to push and what how they'll function at the destination. And just to note that additionally here, you'd probably define things like a table name or user profile. So like I mentioned, we'd make a new connector for this. Here's just some stubs for our Snowflake connector, which pushes and pulls data. And then we register it, like I mentioned we have to do, just to make our connector registry aware of this and able to delegate pushes to Snowflake to your new Snowflake connector. And so putting it all together, what we get is, at the end of the day, and we don't typically run these with CLI, like we have GitHub Actions to do this, but should you be running this on your own computer, you just execute something like dcpy CLI lifecycle, distribute the squirrel census to the Snowflake DB, and then a path to your dataset stuff, or dataset files. And so just diagramming this out, when we registered the connector, we tell connector type is a Snowflake connector, and the Snowflake DB is Snowflake. And so this is pretty much all you need to know for lifecycle distribute to take it from there and push, supposing your Snowflake connector actually gets built out. So when we distribute something like Pluto, it looks much the same. We CLI lifecycle distribute Pluto, open data, and a path to a package. Similar to the squirrel census, we've described where it's going to go. This is Socrata open data, what files we're going to push, and where it's going to go. And so now just briefly zooming in on the open data connector, because I think it might be something that's of interest to folks in the audience, even if you're not using it in the context of the full lifecycle. Yeah, so our open data connector is just largely a Python wrapper around Socrata Pi with some really notable exceptions, just where we couldn't make it, perhaps couldn't fully understand how to do something. So, but it is really tailored for the most straightforward case that we have, which is just I have a data set and I want to push it to Socrata. I want to change some stuff on the Socrata page. And so in terms of the flow of this connector, when I actually execute CLI lifecycle distribute Pluto to open data, what happens? Part one is that we sync the metadata. And this is our challenge as a department, is that metadata means so many things. In this context, I mean the Socrata or open data metadata. So we push all the descriptions, any sort of descriptive attribute you would find on the Socrata page, we sync that over from our metadata. So on our left, we have all the attributes like the pretty display name for Pluto gets mapped straight over, description gets mapped over. Open data considers attachments to be metadata. So as part of this, we sync those over as well. And then part two is actually uploading the data set and syncing column info. So, you know, in our metadata, we've described that we have a CSV that we're going to push as a data set. Part one of the connector flow is to actually upload that data. And then we sync the column metadata, supposing the data set's tabular. Some of our data sets we push to open data are not tabular, like FGDBs, for example, or XLSX files. But supposing you do have something like a CSV, we're just going to copy over, for example, the display name for the column or the description for the column. And then part 3 touches sort of on our internal processes that we maybe publish this, right? So, so far in this flow, the connector has just created a draft. So it's pushed data and metadata to a draft that's not visible to the public. And so you can use the CLI to actually publish the thing, and we typically don't yet. But you know, you only live once, so if you really want to push something, go for it. So yeah, that's sort of the, you know, just a dive into the connector itself. And I'm going to hand it back to Damon to just take us home, and yeah.
Yes, I'm glad we got to give a peek behind the open data that so many people consume and have really hidden the, I don't want to call it chaos, but the volume and flexibility of what it takes to really publish this many data sets. So the outcomes of what we've done is that all of our open data deployments are automated. We do still run these command line arguments, but this is certainly more automated than emailing data to the open data team. I'm trying not to make eye contact because we're sorry. Or the other option that we do still have to use sometimes, logging into the portal and uploading data manually or manually editing metadata. We consider what we're doing now certainly more automated. So scalability, less time spent on distribution means more time on new data sets or improving existing ones. Resilience, you could wipe out all of our open data pages if you really wanted to, but it would only take us an hour or two to get them back up because we've defined those attributes outside of one portal. Accuracy, one version controlled, meaning we check it into a GitHub repo, place for all information about our data sets. And I'm sure Matt appreciates that, so we don't have to keep asking him, what is that file supposed to be called? What are we supposed to do with it? And so just to recap, we shared what we've done with product metadata in general, how that metadata is used to package up our files using our packaging utilities, the flow for automating and distributing these data sets. What we skipped could be a much longer list than that, but just to call out a few things, we also have utilities to mass distribute data sets, and that gets to what I talked about before, the definition of a data product. Something like Lion is a huge set of files. We distribute them one at a time with a command line interface, but using that same CLI, we could say distribute all data sets in the Lion data product, or distribute all data sets in the housing database data product. Neat metadata features, which are some of my favorites, data set defaults or organization defaults. All data sets we distribute are coming from the same organization, and we've prevented repeating ourselves in those individual YAML files by defining some attributes higher up. So if Pluto is just describing Pluto and we want to distribute it, it can inherit some attributes that are at the higher level and say Pluto is by DCP. And snippets like the path to the Bytes website being a URL that we don't want to have to repeat again and again. So I'll just shout out Jinja being the way that we can write text in YAML with little snippets saying there's going to be a variable somewhere that's called Bytes URL. When you end up being resolved to real text, fill in that snippet. And the DevOps/cloud automations around this. We gave a shout out to GitHub Actions because they might be listening, and please don't charge us for those GitHub Actions. Our DevOps around file storage and how we run these actions, we left that out, but happy to talk about it. And so what we're looking forward to doing, a similar roadmap to the last talk, we want to make these things easier to use for us and people that might use this Python package. Of course, better documentation, everyone can relate to that. Extensibility, again, like we talked about, and in this case of extensibility, we don't want people to have to edit a Python package to get it to do what they need it to do. So with the connector registry, if you use this Python package and have other types of destinations you need to send data to, it'd be great if you could write code on the side and have that Python package use it. And outside contributors, as I'm describing. So a lot of users shouldn't have to edit the Python package, but if you have great ideas and want to contribute, that's the type of people we want to be talking to. So in the near future, these are the things we're really focused on. And so getting in touch, we have an email address for the whole team that we strongly encourage people to use if you have ideas, questions, or anything like that. There is a GitHub discussion that we've created in our publicly accessible GitHub repo. If you just Google DCP Data Engineering GitHub, it will come up. And as mentioned, there's a GitHub repo that Finn and Sasha created for the talk that they gave before this about ingestion, but it is the best way to get started with this Python package if you want a great description of how to install it, how to use it for ingestion. You will have access to all other modules in that GitHub repo. So I think that's it for us. Happy to take questions after, but thank you for listening. We might have some online, but if we've got anybody in the audience, we've got a microphone this time. So any questions?
We have one online question. What do you use to manage all of the YAML files? How much do non-technical staff end up having input on items like descriptions and data dictionaries, and how much work is involved with incorporating their input into the metadata structure?
Sure. Yeah, I think it's pretty much, I would say that the main tool we use is just Git. So we have a separate GitHub repo, it's our product metadata repo. You can go pull it up. And so within that, we have just, I wish I could pull it up here, but just every bit of data set or product or org level metadata. It defines all our snippets, et cetera. And there's some sort of quality of life things we've done around YAML. Just for example, like sometimes we have to make programmatic changes to it. Like it functions almost like a database at this point. So maybe you need to run what's effectively like a transformation or I'm sorry, why is the database term?
Migration.
A migration. So, we do have some YAML utilities just around running migrations and making sure that the files that come out of them are consistent. Anything to add?
Yeah, just that for non-engineers, I think we didn't come up with these descriptions for the columns, and we're not the best people to come up with those descriptions. So 100% of the input on these values are from either the GIS team or the subject matter experts in DCP. So we maintain this text, and it is possible for certain users to check out the repo themselves and edit the text themselves. But we might make suggestions like, oh, this seems to be a typo, or we think this would be more clear. But the idea behind all of this is that it makes it easier to get input and ownership over this text than it would be for these values to live somewhere buried in a Python script somewhere, or maybe locked away behind the interface of Open Data where only some people can log in. So for this first pass of creating the system, we did, I think, take more ownership over maintaining the text, but the goal is that non-engineers can maintain this text and edit it and expect to see those changes reflected in the data set.
Yeah, and just one thing, I did kind of space on the latter half of that question, which is just how other teams or other people use it. And so far, 2 members of the GIS team have taken a heroic dive into the YAML. There are tools that we've kind of poked around with using to make the process a little more ergonomic. So we basically for all of our models for the YAMLs that we deserialize the YAML, we just use Pydantic models, and from that we generate JSON schemas. So when you're going to edit any of the metadata, you can do 2 things. Well, one thing right now, but one thing perhaps in the future. Didn't include this on the roadmap, but so since we give you a JSON schema, it's just a description of what needs to be in these metadata files. And so you can load that into VS Code, and it will tell you what fields are applicable. If you messed something up, it'll give you a red squiggly. So that's an example of one bit of tooling that we do use. And then perhaps looking forward in the future, so with JSON schema, you can generate UIs. So there's a world in which we don't have to ask, I think a world that's actually fairly close, where we don't have to ask non-software developers to dive into what is not actually that friendly, a declarative format. So it's definitely in the future. Right now, we're just sort of subjecting technical non-programmers to it. Hopefully, we don't have to subject them much longer.
Hi, thank you so much. Oh my God, this is echoing way too much. But hi, I'm Yuki. Thank you so much for the presentation. I work at another agency in the analytics division, and I also work as an open data coordinator. So this automation is like a dream for, I think, any ODC. So this is amazing. I have two quick questions. One is, did you have to coordinate with OTI when setting this automation up?
This might be more of a Matt question. We just kind of had credentials and we went and did it. So it was more of a directive from OTI that we needed to set up sort of automations on our side to do it, rather than emailing people at OTI to publish data. And
yeah,
appreciate you too.
OTI gave us basically like a guidelines on how to use the API and like a data dictionary of the API, so that data engineering could then develop the Socrata Python.
So the second question?
Oh, pardon.
And what advice would you give to agencies or organizations without data engineering team or a data engineer that can like perform something like this extensively? Like, would you think that, like, for example, my division, which is like analytics division, will be able to adapt something like this?
I'd say yes, and it's important to work incrementally. And I think that's where the value in just writing these things down first is really important. You know, whether it's, okay, we don't want to use DCPy, we don't want to use this product metadata or command line stuff. If that's a technical decision that is made, I still think the value of writing down the things that are currently managed in what is essentially a CRM, open data, is valuable. So that can start at any time, you know, writing them in a Word doc, writing them in a text file, in a YAML file, just having them live somewhere other than our heads or emails or a portal that you may want to overwrite someday is, I think, a great first incremental step. And then the idea behind not having to write any Python code to use this, I think, feels like a natural next phase of technical difficulty to use something like this to automate the actual distribution of things, where, like the ingestion talk, with a relatively simple text file and pip install DCPy, you could then run a command line argument to distribute that data, hopefully as a draft first, and don't overwrite what's on the publicly available page, and then just continue advancing the use of it if this is a tool that you would find useful. But cannot stress enough the value of just incrementally, you know, getting to a place you want to get to.
Thank you so much.
Yeah, and I suppose just to add to that, like, I think you'd probably encounter some difficulties in the current state, but a lot of the impetus for us giving a talk like this is that, you know, with the existing stuff we've done, it's just a short increment for making it usable to a much broader group of people. We just need some glue code, and we unfortunately don't always have the time to do it. But it's incredibly helpful to hear that like a less technical version of this might be helpful for other agencies.
We have a couple more online questions, two from Rosalind David, so I'll give them both. First, am I correct that the destination is defined both in the metadata and via destination-specific connector? If so, what's the purpose of that redundancy? And then I'll ask the second one after.
I think that's partly true. So connectors are the code that define how data should go to types of destinations. So let's say there are two FTP servers you have to send data to. There might only be one FTP connector. And you can describe those two different destinations of the same type in YAML. So maybe that, to me, that's the nuance. That it's partly true that there's redundancy, but if you have two different destinations of the same type, you'd only have one connector.
So in terms of redundancy, it's like on the left, I'm assuming this is the slide in question. Please correct me if I'm wrong, but so here, really in the metadata, what we have on the right where we say Snowflake here, this is just the directions to lifecycle distribute to say, hey, when you go to push this thing, just go find the right connector in the registry and execute that thing. So I guess I'm not entirely clear on where the redundancy is.
Yeah, if we want to just hit the second question. That's fine.
And then the second question is, who writes the descriptions that go into the metadata and data dictionaries?
You do.
Yeah. So this, again, sort of, there are a lot of answers for that. And part of the big iceberg that I didn't mention as part of this project is just generating the metadata for the entirety of DCPs, of all of our data sets, right? And so we have a variety of tooling to make life a little easier here. So for example, if you have a shapefile that has descriptions or column attributes in it, we have tooling that will just convert that to our metadata format. Okay, cool. If you have that, you can then generate like the Open Data XLSX or something like that. We have tooling to pull it from Esri servers and include some Esri metadata, which is really gnarly. But short answer right now is just we had to cobble it together. So I oftentimes would go just copy paste from existing READMES or something like that. And then when in doubt, so Matt's team is the source of truth for all this. And so one thing we're really looking forward to is actually just getting in like a code review cycle with them to like, hey, someone's going to go change and go add the word "the" to the description of Pluto. Like, let's have a review process around it. So the short answer is just a ton of different sources for what eventually became the metadata.
Yeah, and I was going to say for the other question, but it's relevant to this one too, is that the OTI Open Data team's data dictionary lines up well with the metadata that's needed for the Open Data page. So if you're already filling out those data dictionaries for your Open Data products, a lot of that metadata can be just sort of pulled or translated or copied from that format into the YAML.
Yeah, time. We have.
Yeah.
Got another online question or?
Any other questions in the house?
Hey everybody, Fuad, Children's Services Analyst. Would love to hear what are like the next developments that you guys would love to work on, and what are the dream projects if you had more, I don't know, staff or superpowers. I'm sure you have all the superpowers. Thanks.
This is the most fun question. Thank you. So one of them I mentioned before was just sort of tooling to make this more broadly applicable, like so that you don't actually have to write code to do any of this. So I think from that perspective, like tooling to just like generate UIs to generate metadata. So like maybe like this could take the form of like effectively like a form on a website, just something where we don't have to have non-technical people. Sorry, I just gestured at Matt, but Matt's a very technical person. Just, we don't want your average person necessarily doing that. So I think there's just a lot of glue code. It's just the type of thing that would take, a clever developer a few hours to do. One thing we're sort of delving into right now is, so we generate from the metadata, for example, like, I don't know if folks here are familiar with like the XLSX, the data dictionary that OTI requires. Like we generate those things now. We just take our metadata and we just look through it and spit out an XLSX file. We're currently in the process of working on READMES and like PDF data dictionaries and that type of thing. But you could zoom out a little bit and say like, why not just generate a catalog explorer for all of my data sets? Just generate me the documentation for everything in one go in a little website that people can use. Those are what spring to mind. But then also just, we kind of alluded to it that right now, like we have the capability to distribute, say all of our data did go down tomorrow. Like it would be a bit of a kludge to, we'd be stringing some bash together. There is an elegant way to do it that is just right here. And we need just a little bit more time to work on that sort of thing to get to the point where we could, say, distribute all all of my data, just all of it, and go. And so that's probably my thoughts for immediate. Damon?
I'm glad Alex gave an answer very relevant to the talk, because mine might not be. And it's 2 quick descriptions of dream projects that we can certainly talk about later. One is making QA of our data before we distribute it, before we package it, more pass-fail, and less humans inspecting things and having to find issues themselves. And that's ongoing work. And the other, in my mind, is what I'll just describe as one pipeline for all of our data products, partly because they use so much of the same source data. And we started out by inheriting, I'll say, dozens of separate GitHub repos that each build a different data product for good reasons. We decided to create one repository where all of that code lives. And I think our natural progression is that this is one pipeline where you hit refresh and our data sets update, I don't want to say daily, but weekly. Instead of them being so batch and independent of each other, I think we see a lot of value in combining these things in a healthy way into one data pipeline, and then our data products are just exported snapshots of New York City geospatial data. So we could talk about that for days, though. So, yeah.
We have another online question. This coming from, excuse me, coming from Michelle Villavicencio from ACS. What are the ramifications of necessary changes to the dictionary to this process? And there are a couple little follow-ups here. So, especially with law changes such as MENA, M-E-N-A, which this might be a Matt question. MENA, M-E-N-A.
I think maybe to the broader first half of the question, we would just have to, and I'll interpret that as, say, like new fields that you have to populate in a data dictionary. We would accommodate that by adding what we might consider custom fields, but adding fields to the YAML that we have to write so that when our tools go and populate that Excel file, it's able to find the relevant cells, or the Excel template that we're starting with in the first place has those new fields so that they can be populated. So I hope this is answering the question, but I think the idea of what we built is that it's starting with a template that we have to populate. And if the template changes, then we use a new template, and we add just enough new attributes in that YAML so that that new template can be populated with the fields that it has to be populated with.
And I think there, without knowing more detail about the question, there are 2 things that sort of categories of what my mind jumps to when we talk about changes to the metadata. We could be talking about changes like on our end to the actual structure of our metadata, so breaking changes for users. That's a rabbit hole we haven't gone down yet, but it is part of sort of the question of open sourcing things. But I'm guessing that the actual, what the questioner was asking was more along the lines of, say we do make a change to the description of a data set or something, is there legal ramifications to, like, do we have to make sure things are in line with laws, for example? And that's very much a Matt question. It's very much beyond my pay grade, and I would like to keep it that way.
Yeah, and we just are following the open data laws, and so if there's changes, we're making sure that we're going through with our counsel to make sure that we're complying with all those open data laws. But mostly it's just going to be like a schema change, adding a field or changing a field. And those things are hopefully coming up further upstream from the data owner, letting us know so we can change the metadata, work with data engineering so they can change their templates to then feed that pipeline.
And then just to add on that, I think in such a case, this approach is a great win for transparency, which is one of the reasons we're here, which is that when we would be involved in that, like changes to metadata with, for example, the GIS team, like the metadata itself is public, conversations are public, and so it's I think a win for transparency just to have both the changes and the rationale and the discussions around the change publicly available for people.
Any other online questions?
Yeah, there's one more online question also from Michelle. How difficult would it be to edit data migration from connections to New York City database sources?
Can you reread the question?
Yeah, maybe I'll ask for a clarification. How difficult would it be to edit data migration from connections, maybe connectors, to New York City database sources?
Interesting. So in theory, you know, if you were adding a new, like, you know, to take my squirrel census example, where my boss came to me and said we need a Snowflake database or something. In theory, it's just as simple as adding. Okay, this is me, the open source developer, talking. I have mostly publicly available APIs to hit. But we actually do encounter a lot of problems like this with city planning, where a lot of our data is very secure behind a firewall. And so, you know, that's going to be it would be a similar solution from the, you know, you'd have to just create a connector. In our case, it's kind of we haven't actually gotten behind the wall yet. But, you know, in theory, you would need just a connector that can jump through the hoops of, say, going through a firewall or communicating with an agent on the other side. So, you know, it actually, right back to your question, like what sort of next for all this is, like, for us is how do we actually interact with data behind the firewall? And so we'll need to set up some agents probably inside the firewall that can communicate with the connector, and it's going to be very difficult, but which is why we haven't done it yet. So yeah, I completely, so that's all to say I can commiserate that there are hoops to jump through, especially in public government. We're very, very lucky in that we don't have to jump through too many of them. We have public data sources. Sometimes, for example, we have to go grab files off an SFTP server, so we create a SFTP connector that, you know, we find a secure way to get a key file into our build environment, or sorry, our distribution environment, go pull the files, put them somewhere, and then call it good. And so, yeah, it's really all the complication, I think, would arise with the connectors. And so in the metadata for such a scenario, you would just really be defining sort of the maximum number of details you could get that are public, right? Just you'd need to tell the connector where to go, but any sensitive details would need to live probably in whatever secret manager you use. That was very rambling. Did that make sense to anybody? Sorry.
And we have one more online question. Have you corresponded with other agencies to provide similar tools for their reporting? Does this look like the future of reporting across NYC?
Now we have. Future is now.
Reporting?
Yeah.
Maybe just overall distributing.
Oh, sure. Yeah. So I guess something I tell all these folks frequently is that I forget who the quote is from, but if you're not mortally embarrassed by the quality of your code, then you've shipped too late. And so here we are, shipping to you. We're mortally embarrassed by a lot of it, but yeah, part of the impetus here is just to get, you know, to both build awareness, but to potentially bring on contributors and to hopefully be useful to other agencies.
Yeah, and it might be a little less reporting and more distribution, but I think this is something that you're definitely willing to share with as many agencies who would like to use it.
For sure. Okay. Thank you. I think that's all the questions.
Thank you so much.
Seems like people are looking for direction. The next talk is in 20 minutes, half an hour. All right, so we'll see you back here hopefully in half an hour.